Okay, hello again. I'm going to talk about our two NetApps within the project. The first one is a little bit more detailed, but let's see. Our first NetApp in the context of 5GAS is the virtual onboard unit. The idea that we have with this application is that we have the physical obus located in the vehicles, and we try to provide a virtual, let's say, a virtual counterpart, a virtual OVU in the mech, in the cloud, near to the vehicle, and connected in this way also to the cloud and the core network. So the aim of this solution is to provide that's the virtualization of the vehicle OVUs to, in first place, reduce the latency in the communications with the vehicle from the external network or from the core network directly to the vehicle, and also to provide some kind of offloading capabilities to the virtual OVU located in the mech, where we have more computational capacity. What do we get with this? In first place, we obtain robustness against these connections, as we have this kind of virtual entity that it's like not in that sense, but like a copy of what we have in the vehicle. So when the vehicle, for some reason, we know that in vehicular networks we have some kind of problem with the disconnection. So we have that information stored in our virtual counterpart in the cloud. So we are still able to gather some information and to continue monitoring the services. In this way, we also save radio resources because it acts also as a cache. So we don't always have to go till the final mile, till the vehicle, but we can just go to the mech, or even if we have the information enough updated, we can go directly to the cloud and gather that information. So we also improve the data processing performance in the general architecture, and always depending on the use case we had. So that's the general overview of the application. Here you can see the architecture of the application itself, not the NetApp, but as you can see, we have different components. We have the application located in the physical OVU, which at the end it's connected to the network. Here we have the 5G connectivity, but it can also be obviously vehicular through vehicular communications. And then we have the virtual counterparts located in the mech, where we have them ready to be used and to be assigned to a physical OVU. Okay, and then in the cloud we have the manager and the data aggregator that make all these. The manager obviously manage and orchestrate the virtual OVUs and the location, the communication, etc., the instantiation, and also the release of the resources. And finally, we have the data aggregator that it acts as a first entry of point to the system. So with that, we can also achieve some kind of caching in the cloud. So the access is direct. We don't even have to get to the mech. So that the request go through all the path. And in case we don't have the worst case scenario is that we don't have it catching in neither the mech or the cloud, so we have to go to the vehicle. But in the majority of the cases, we can avoid that full connection. So from a more practical point of view, we have in the 5GAS project, we have effectively convert the application into a NetApp. We have gone through all the methodology process we described earlier, and we already have a first proof of concept of the network application. For example, here you can see obviously the local deployment, still not in the whole 5GAS framework, but using the same technologies and using similar approaches. Here you can see the instantiation from the OSM, which is our NFPO, and in our local bin, the OpenStack, so we already have the application deployed. And here you can see the operation of the NetApp. I know it's difficult to see exactly the details in the slides, but in your left you can see the overview of the car, that it is registering and requesting a virtual content part that can be seen on the right side in the manager that received that petition and instantiate the virtual OVU on the mech. So then we have that whole path with the virtual OVU in the middle. And regarding, for example, the state of our network application, we already have, as I mentioned, the first beta version. We have it designed, developed, and we have even performed some local testing using the robot framework and the kind of a subset of capabilities of the CI/CD manager that was presented before, not in an automated way, but in a manual way, but we are on it. So we have this first proof of concept. So we have already deployed it using OSM 8 and 10. We are also eager to try the newer version to see if we can adapt it easily. We have already deployed it with OpenSlide, which is what powered the 5GAST framework using a local, again, instance. And we have already onboarded and tested it in our local proof of concept scenario, and we have achieved to connect between the entities. So as a work in progress, for example, we are performing some minor code debugging, and we are developing more tests for the application. In this case, we have tested it from the point of view of the infrastructure, just some latency, bandwidth, and connectivity, etc. test. But now we are more interested in making tests, operational tests, functional tests, to see, for example, if the application is working correctly, if we are, for example, correctly answering the HTTP request to the API, or, for example, if we are effectively reducing the latency of the access. For example, asking for a data, for some information that it is already cached, or information that it is not, so we have to go through all the path till the physical overview. And well, in future plans, as I said, we also want to adapt it to Kubernetes and maybe some changes in the management of the virtual OVUs. Okay, I will go directly to the next NetApp, so because they are related, or there is.
We have one question, so let's take that before. So you are complimented for the interesting architecture. Does the orchestration stop at the edge, or does it also include the OBU resources, energy consumption, etc.?
No, for now we stop at the mech. The application, the NetApp itself does not include the program that is hosted in the physical OVU. We stop at the back, but we are also exploring new possibilities, and that can be an ICD and also a great question.
Thank you. Now let's move on to the next step.
Thank you, Monica. Okay, and moving on to the next NetApp of Odins in the context of the project. Here we have the multi-domain migration NetApp, that it is kind of an evolution of what we have seen with the virtual OVU. But introducing the, let's say, the mobility between virtual domains. So we have as a starting point, we have the virtual OVU as the representative of the physical OVUs. And once we have that, we considered support the mobility over virtualization domains in the way that we know we are in a vehicular scenario. We know we have mobility. We have to have mobility consideration of the vehicles. So we have, in some sense, to try to follow the vehicle through the network, and that's the main idea of these applications. So we can follow the physical devices and maintain this quality of service and these capabilities that the virtual OVU is giving us. So, for example, if the virtual OVU is instantiated in one mech, if the vehicles keep traveling, we will lose that. We will lose that capability. So we will try to follow the physical device. Obviously, we use, as I mentioned, the technology we use in 5GAS, such as SDN and NFB as enablers to make this possible. And what we get, seamless transference of these VNFs between the different domains. We also obtain no data losses because we try to maintain the status until the new instantiation is ready of the virtual OVU. We achieved a low migration time between domains, and we make it transparent for the final devices. Here, for example, you can see the similar architecture as with the virtual OVU, but with some difference. For example, here we introduced the virtual. We have the controller, which is now we have a controller for each domain, obviously, and then we have the data aggregator, that it is the common and single entry point we have earlier also. And here we introduce also the distributed database, so we have to you have to have that information available into the multiple domains, and these databases have to coordinate among them to have the information available. For example, here you can see also another entity, the SDN controllers, because for now in this approach we have, we use that SDN controllers of the domains to try to redirect the traffic and make it seamless. Okay. And well, finally, again in the context of 5GASP, we have the NetApp in. This NetApp is in less evolution stage at the other one. We have designed, developed, we have tried local instantiation, but we still have some problems, and we are trying to make it as synergized as possible with our first NetApp, that is the virtual OVU. At the end, as I said, this is an evolution of the first one, so we are working on that. Indeed, we are studying the fusion between both of them, so we can have, let's say, just only one set of descriptors, etc., but with the full capability of the virtual OVU. We are also developing some tests in the same way as the other one, and seeing another alternative to keep that connectivity, to make it seamless and to keep the connectivity between the virtualization domains. Wait, that's all. I don't know if is there any question.
You mentioned following the VOBU. This brings in mind the previous two NetApps presented by DriveView and the University of Bristol. Are you working together on combining approaches like traffic, trajectory, or handover predictions to assist your NetApp?
We are not still collaborating, but we have had some conversations, and we are exploring maybe the collaboration. As for example, I think we can obtain nice synergies among these NetApps, and in the context of the project, indeed, we have envisioned some kind of collaboration in cross-vertical use cases. So, I think nice suggestion.
Thank you. Yeah.
How are you deciding right now in your NetApp to migrate the VNF to another one? Are you using which type of algorithm, or how do you do the handover basically?
No, for now the handovers, I think we made it with position, as we made it in a very controlled scenario, so we don't have that smartness in the solution yet.
Thank you. Any other questions, Luca?
So, my question is, if you lose the connectivity from the car to the virtual OVU, are you collecting the data locally in the car and then push it?
Yeah, of course. Yeah, the idea at the end is to have like, I like to compare it with a cache, a distribution. So when we lose connectivity, the data is stored in the car and with the history of the data, and then the virtual OVU try to gather all that lost information and try to keep the data as updated as possible.
Great, thanks.
And forward it to the cloud also.
So you said something about custom test VNFs. So what kind of VNFs are, what kind of custom VNFs are you using?
That's more, I think the name can be a little bit confusing. This is another kind of test option we have in the project, in the way you can create a VNF that is somehow associated to the NetApp, so you can deploy and use it as, for example, a client. Instead of giving the option of a script, you program your script and deploy and execute the test, to have a VNF that acts, for example, as a UI or as a client. And for example, in our case, we for example, are thinking in creating a VNF that hosts some kind of data collection mechanism that make that petition to the API and acts as a client, as a real client in the real world.
Okay, thanks.
Thank you. I think this is it for the questions. Thank you very much.
Thank you, Monica.
So this has been a bunch of interesting presentations. We know it's tiring to look through such different information. So we take another break now. We come back with a very interesting and challenging subject of the certification process we are building in 5GASP. Then we will see some more presentations of NetApps, discuss a bit with colleagues in another similar project that's about Vital 5G. So join us in an hour, enjoy a break, catch up on your emails or some snacks and coffee. So we'll be back at 2 p.m. sharp CET, 3 p.m. in Romania. Thank you.